All right. Hello, everybody, and welcome to the Big Data and AI webinar series. We're really excited to have you all. We hope that you are safe and healthy. Just a reminder, new webinars are being hosted every Thursday. So make sure to follow us on LinkedIn and Twitter to keep up with the latest and greatest that we're putting out, and to make sure that you don't miss any of our webinars that we'll be hosting. So we're going to jump in. Looks like most people are coming on and we're getting ready, which is perfect. All of our speakers are here. So today's webinar, we're going to be focusing on designing your AI deployment. So you've done all the research, you know all the strategies, you've heard of all the solutions, but how do you actually get started? How do you actually start deploying these solutions and these strategies in your teams and your enterprises that are going to have an effect, a successful effect? So today we have three amazing speakers for you who are going to be talking on this topic. And first up, we have Conor Jensen, who's the Director of AI Consulting at Dataiku, followed by Ramy Nassar, who's the Head of Innovation at Mattel, and also the author of the upcoming AI Product Design Handbook. And then following Remy, we have Salman Amin, who is a partner at Learners.ai. So if you have any questions for our speakers, we ask that you put your questions in the Q&A tab. So this tab is located to the right of the webinar screen. You'll see that there's a tab for chat and there's also a tab for Q&A. If you put your questions into the chat, we may not see them, and therefore we might not get to your question. Additionally, make sure to add your questions as the presentation is going through, even if you're not sure if the presenter is going to talk on that question that you have, just to make sure that your question is in there and we do get to it. If the speaker does get to your question and answer it before the question period, we'll make sure not to ask that question, but this is just to make sure we know all the questions that are coming through. If there are any questions that we cannot get to today, we send those questions to the speakers and they have the option to answer those questions, and we send them out to all the attendees. Our webinars are all recorded. We do not take any breaks through the webinar. So if you do have to take a break throughout the recording, don't worry, we do post the webinar on our website afterwards. So don't feel like you're going to miss anything if you do have to take a quick break. So we are going to get started here. And as I stated before, our first speaker that we have on our docket is Conor Jensen, the Director of AI Consulting at Dataiku. And he'll be talking about deploying data science at scale. So Conor, I do see that you are up and running here.
Hey, hopefully you guys can all hear me.
Yeah. Yep.
All right, let's go. Get ourselves back to slide one and let's get going. So, good afternoon, everybody. Excited. Thanks for joining. Excited to talk a little bit on the topic here around how do we put AI products into production? What does deployment mean? Very important topic that's near and dear to my heart. For just a little bit of background. As introduced, I'm the Director of AI Consulting here at Dataiku. Dataiku is a data science platform, very much focused on the ability to take your data from original data sources through to all of your data munging, transforms, etc., build models, but very specifically, and what originally brought me to the company, the ability to automate and push things to production very easily. I spent nearly 20 years in the data science space, I guess under various banners. Studied mathematics in college. I was a weather forecaster in the military before moving over to the corporate side, where I spent about a decade in insurance doing catastrophe modeling, actuarial science, data science, as that's kind of come to the fore. before moving over to the product side, where I've spent the last 3-4 years now at data science companies, working with customers and helping them do data science and helping them use our platform. So getting specifically into what does operationalization mean? What does deployment mean, right? These are words that we use a lot, but there's a lot of kind of confusion, or there's a lot of different ideas around what that can mean. So what does that mean to us? How do we talk about this here at Dataiku? We look at deploying data science really from 2 lenses. And the first one is O16N, or operationalization. We're founded in France. Our French colleagues, operationalization, aside from being a ridiculously made-up IT word, is also a little challenging to say in French. So often we say O16N. And so that's really deploying models to drive business value, right? That's taking the model that a data scientist has built and getting it into the hands of end users. But the flip side of that, that's also really important, is self-service analytics, quick answers to unformulated questions. How do your kind of like rank and file business users, how do your executives, how do they answer their own questions? So briefly, to give a little bit of a better definition around those, what does it mean? Self-service analytics. Self-service analytics is finding quick answers to unformulated business questions. So this is beyond business intelligence. This is beyond having a dashboard where you've specified these are the things I need to be able to answer, or these are the questions I have. It's giving people the power to answer questions themselves, going from data to structuring the question to answering that answer. It's trying to empower more people around your organization to do this sort of exploration themselves. There are still really hard questions, though, that do need data scientists, that do need AI answers, that really need proper projects and work behind them. That's where then the operationalization side of it comes in. And this is, how do you impact business processes with models and data flow, right? How do you take the data science projects that your kind of high-powered advanced analytics groups are building and distribute them all over the business? And so today we'll focus more on this second question, right, around the operationalization side of it. Though remember the self-service analytics, because we'll definitely touch on it as I give an example of one of the customers that uses it and how they've done so. So let's talk about data science, right? What does the typical data project lifecycle look like? So if you think about it from the data science perspective, there's different ways that people envision the lifecycle, but it's a fairly standard sort of thing. Get a question, pull some data in, do some exploration and analytics, prepare your data, build a model, test it, iterate on this until you're happy with it, and then deploy it. And when you're thinking about it from the data science, the data science department, and you think about it, this is kind of like what we do. We pull in, data, we munge it, we test things, we build different models, and hopefully, not always, but we come out the other side with the model that we think helps to answer that question. And then it deploys. Well, but what does deploy mean? And that's where operationalization comes in. So let's take a different view of that life cycle, where what we showed up before there, this deployment, or this production and design cycle, is really just these first 2 points of ideation and design. Sample thing, depending on the data, especially if it's data that you're familiar with, design could be fairly quick. Sometimes it's longer, but it could take 2 weeks to get data and build a model. Certainly if it's data that you're familiar with and it's a question that you have a notion for, you can design a model pretty quickly. But then productionalization, how do you take that and build it into your front-end systems in a way that they can ingest it? Did you build your model in R? Did you build your model in Python? Does it need to be recoded into Java? Does it need to be develop an API that you can hook into some sort of front-end system? And then once you've actually taken your designed version, built a prod version, now deployment, right? Actually going through change logs and testing and working with IT to make sure that it's not breaking anything. And the other side, training people how to use it. And then finally the execution side. And then that's an incredibly critical part here, because execution, until people are actually using the model that you created to make new decisions, to change, a product cycle, to sell something differently, whatever the business problem is, then the model is just fancy math, right? Or maybe it's really simple math a lot of times, right? So until you're actually seeing people use those models, there's no business value being generated here. And so when we think back to, just hopping back here real quick, this core part of it that we're thinking about it from the data science side, has nothing to do with actually driving the business value until we've done that deployment. But here we're really showing deployment can take far, far longer in many cases. So operationalization, O16, is really the steps between having a model and then actually getting it deployed into the hands of all of the business users that need to use it and generating value. And honestly, 80% of that work is here in this operationalization phase. Building the model sometimes is the easiest part. The math is easy. Getting it, training people, getting it integrated into your front-end systems is incredibly hard. Here, giving at least a little bit of a flavor around some of that, data scientists, it's a very new field. The tools that we use are very different. Using notebooks, it's new technologies, often open source libraries through machine learning or other deep learning things. It's entirely different paradigms, right? Like how data science explores data, builds its models, pushes models out, tracks the performance of a model, right? Is a model performing is very different than is this code executing. So these are the things that data scientists are thinking about. But then IT needs to have like stability and systems that are easily maintained and they're updated. They need to know who supports it. Like once a model goes out to production, if that model breaks, who is called, right? If the data scientists wrote it and it's built in some Python and they just push it out and it breaks, IT doesn't want to be on the hook to fix that model, especially if it's sitting in some customer-facing system. And especially because of the frameworks, right? Like how are you deploying it? Does it fit into your existing architecture? I think back to the days of building models in SAS where you weren't using SAS to productionalize, you didn't have the capacity to do it. And so you kind of formulate your algorithm and then you'd spend, hopefully maybe 4 or 6 months building the model, getting all the data, building the model to do that. Then you'd spend 12 months working with IT to rebuild that algorithm into Java, which was hard coded into our front end systems that didn't have, the ability to interact with the REST API and pull that sort of thing in. And so, we were spending far, far more effort on this operationalization side of it to make sure that like what was being pushed out was something that IT could support. So we had to train them to be able to do these. So how have we seen customers actually like take this and take our platform and really up the game for how they're doing this operationalization? So I'll give a little bit of an example for GE Aviation. Been a customer with us for about 3 years now. One of our largest customers and certainly one of our most advanced. We love working with them. So let's talk about like what have they done to solve these problems to make it so that they were able to empower all of their business users and move models out faster. So GE Aviation, like many big companies, struggled with people in silos all over. And where have they gone? They've gone to having 2,000 plus people on a self-service analytics system. I'll talk a little bit about what that actually means. 130 published data sets in the last year, so they're giving people the ability to build and push out data so that, again, that self-service analytics, people can answer their own questions with data that has been kind of like blessed and pushed out by the data science team. They've created thousands of data products. And here, and I think it's an interesting point to note where I say, hey, I'm talking about thousands of customers or thousands of projects at our biggest customer, but still for them, only a certain proportion of them are in production, but hundreds of models in production. And here they have 568. This is an old enough slide that I have no idea what the number is today. I know it's higher than that. Automated projects, right? Something where somebody has built those answers, those model that is always being updated and pushed out. So how have they gone from these silos to this sort of thing with thousands of users, thousands of models, and hundreds of models in production and automated? So the question was how to scale. They had small teams that could do things well. They couldn't do it large scale. And so they said, how do we make it so business owners can deliver their own data innovation? So they created a team called their self-service data team. I won't go into the details of how that team is comprised, but I will talk about like what they focused on and how they enabled the people about their organization to do this. So they really went through how do we focus on operationalizing two things. One, automating production, right? So I kind of talked through some of these challenges around reformatting, building new systems, integrating data science, processes, et cetera. So they said, how do we automate the production of these models so that anytime a data scientist or an engineer or an analyst builds a new model, they can automate. So first, the data sets are available. They have the data sets available to everybody. This goes back to that self-service analytics part of the operationalization, so that anybody can go in and access the appropriate data with the knowledge that this data has been kind of like curated and built by their data science teams to be good and clean and well structured. They can go in and access that data to answer their own questions. They also have self-service data can use any data set to create projects in their design environment. So they have their own environments that everybody has access to that has those tools within it. So they have Dataiku, they also have some data cataloging and other tools. And so they've given everybody access to these tools so that alongside that data, where you pull that in, here is now how do you have access to those tools. It's not downloading something and doing it in Excel. It's not, it's all packaged there well together. Once they've actually designed a project, both the data prep, but maybe built a model with an output that they need to use, they can promote from their design environment to a production environment that other people can use in one click. And the important part of that was automating the checks. So 3 and 4 here really go together. So this is an IT designed process where instead of it being, hey, I've built this thing, I need you to go automate this IT, the data scientists, the engineering teams worked together to build a process where a user pushes it. There's a set of scripts that run in the background. It moves it from their design environment, which is federated from their production environment, automatically with a set of checks to make sure that everything runs, right? So it does a code completion check. It does, data validation checks. It kind of goes through, they figured out what are the manual things that when we ask for a project to go to production, what do we test? Now we can check all of those automatically. If it fails, then it goes back and the person needs to rerun it, or it can go to an exception project. The other side of it, and I mentioned this around the stability and the who owns things, the IT concerns, well, what if a model breaks? What if we've actually produced this, productionalized this model and it breaks? So now when something does, they have automated failure handling that hits both IT and whoever owns and productionalized this project. So first, there's an email automatically sent to the self-service data team that manages the platform, as well as the product owner, whoever it was that had pushed this from design to production. It automatically tries to rerun the scenario. So it will try again. Scenarios is what we call our kind of automated platforms. And so it will automatically try it. Sometimes a bug just happens, right? Like things fail, there are hiccups in the system. So it will, if it fails, it emails you. It tries to run it again. If it doesn't do on the rerun, then kind of closes down whatever that process is, and it goes back to that owner. So it doesn't spin off to infinity, consuming resources, but it does do that automatically notification so that somebody can go in and fix it. But it's going back to the owner. The self-service data team, the centralized team, knows that it's broken and can follow up on it, but it's not their responsibility to fix it. It's the original data science owner that needs to go in and fix that. And so what does this actually enable them to do is that they have people across their entire organization. Engineering, so again, this is not just data scientists that are using this platform. Engineering is using data to do redesigns of parts and do more efficient manufacturing processes. So like real impacts on their production timelines. They're updating and improving their supply chain to get better data insights. Finance is using it extensively to do some of their analysis that they previously had done in Excel or other desktop tools. And their sales team is actually being able to say how do we transform some of this data into insights to tell our customers what we are understanding about how they're using it, right? So they're using it all the way throughout their organization. This kind of core central team is being able to empower a whole huge piece of it. The last thing, and then I'm happy to switch to answering a couple of the questions, is you have to be sustainable about how you're building these things, because we see this technology moves and changes, it goes all over the place. So how does this how do you do this in a way that that what you're productionalizing today will still be relevant in 5 or 10 years, even as things are changing? And a big part of that is having systems that are built where you can leverage the existing technology using the current infrastructure, but separate some of that design and build from the underlying pieces, right? So this is where we get to some of that end-tier architecture, that was a really popular word a couple of years ago. So you can use the infrastructure that you have today while building, essentially a platform on top of it, where you're doing your design and the development of analytics in a separate place where then you're actually like hosting and running your data. This allows you to incorporate open source technology. It allows you to extend it based on different requirements as it's coming. And that idea of making sure that while you do have to make bets and you have to pick something, you can't just, unless you want to build it all yourselves, which is incredibly challenging, you do have to make some bets on what you're choosing to do, but you can do your best to, choose the platforms that allow you to use what you have today on premise, in the cloud, et cetera, while being able to incorporate the things that are coming down the pipeline, especially in this fast-moving open source community that the data science world lives in. So thank you. I've seen a couple of questions in the Q&A here, so I'll do a quick time check. I think I've got 5 minutes to do some questions and answers, so I'll do my best to get through some of these. So the first one I see in the Q&A, Faisal asks how to deploy deep models. So I assume you're talking around like deep learning type of things. So this is in the same process for us. And so to not go too deeply into it, the way that our architecture works, if you're deploying it using Dataiku, is we have either automation or real-time API scoring that are built on the same kind of underlying architecture as the design nodes. And so any project, once it's developed, assuming that you're preserving the data connections or you're updating them to be production data connections, that same project, that same architecture can move over and live in your production environment. So as long as you have the appropriate kind of like underlying architecture, necessary either GPUs or something along those lines, and you're using the right libraries, deep learning models would be deployed in the exact same way that you would deploy any other model in Dataiku. Can we add Dataiku to any platform? So hopefully I'm interpreting the question correctly from guest 480, but Dataiku is a we say on-premise, it's not quite the right nomenclature. Essentially, you can deploy it into any architecture. It's designed to be installed essentially on anything that is a Linux server. So we deploy significantly into the cloud, any 3 of the major clouds, as well as we have customers using some of the more obscure cloud providers, as well as you can do it in on-premise. We interact with Hadoop, we interact with SQL, we interact with kind of any of your major data stores to be able to add that analytics layer on top of it. So hopefully again, I'm doing my best to interpret the question, so hopefully that was the right one. Mike asks, so about what is the future of self-service analytics? It's a big question. So, I'll give a little bit of kind of my like opining on that. For us, we see that being more and more important, right? As you think about companies becoming data-driven, which I think is something that we've talked about for the last few years, but moving more than even to being like AI and data science-driven, not just data-driven, what does self-service analytics look like? You have people throughout your organization that are extremely knowledgeable. They know your domain. They know the challenges that you face. They know your data. They know your customers. They know your problems, but they're not data scientists. They don't know how to code. They don't know SQL or Python or R or any of those things. And so self-service analytics becomes more and more important by giving them access, again, not to just data, not just to, oh, here's this thing where if you go lean SQL, you can use it, or here's this data warehouse where you have to go spend a ton of time understanding how we've organized the universes and put all of your data together, making this easier and easier to be able to do what does the self-service analytics look like. It is giving people access to the data, but it's also giving people access to the tools to be able to do the interactions with that data and answer their own questions. It will become absolutely more and more important going forward, is very much my view on it, and certainly our view as a company. But that's also fueled with the need for deeper and deeper data science, where you're starting to tackle these really challenging questions. Certainly when I look at starting data science teams at organizations, sometimes the first projects you're doing as a data scientist are, I need a dashboard to know how many units I sold this month. I wish that was a made up example, but it's a true story from a company that I worked with a $600 million business unit that didn't know how many units they sold per month. And so our first step was really just building them the tools, the dashboards, et cetera, to be able to go answer these questions themselves so that the leaders in that unit could do this sort of what did I sell? What products were the most profitable, what's products sold the most, where are we lagging, that sort of thing. These are not real data science questions. These are the sorts of things that we need to do more and more, because data scientists end up answering these questions because people don't have the tools or the access to data to do it themselves. I'll answer. So then Stephen, let me read this. So a newbie question given machine learning and AI is about ingesting and analyzing large amounts of data and building a model for interpretation from that data set. How does one handle new releases and updates? So big question with a lot to it, and I'm at time, so let me like do a short answer to it, and then I'm happy to kind of write more to this question again. So we handle like code environments essentially, and so when you push something to production, it's published with the existing code environment, so whatever specific packages and libraries were germane to that particular production version. Anytime that we update our core software, which has some like AutoML pieces built on top of open source Python libraries, you do have to retrain all of your models, because sometimes that has impacts on kind of the underlying algorithms or how things compile. And so anytime you do kind of a full upgrade, you have to retrain everything in your dev environment. But from a production standpoint, everything is frozen, with the existing code environments as you push it out. So then when you do your testing from a V1 to a V2, V2 to V3, if you've updated those code environments in the background, you need to kind of make sure that you're doing the diff and understanding the impacts that you have. So, all right, that was, let me stop there, get on to the next presenter. I don't want to take up too much time. I'm happy to answer the existing questions that are in here later, or if you submit any other questions, to the team, I'm happy to get back to you in the next kind of 24 hours and help out. So thanks for the time. It was a pleasure being here.
Perfect. Thank you so much, Conor. We really appreciate you taking the time to speak to us. Fantastic presentation. And just like Conor said, we will send him any questions we didn't get to for him to answer after the webinar. Just a quick reminder, some people have been asking, the webinar is being recorded and will be available on our website after we've concluded here. It should be available probably next week. Additionally, just another reminder, make sure your questions are going in the Q&A tab and not the chat tab. So thank you, Conor. We really appreciate it. And we are going to hear from our second speaker now, Ramy Nassar, to bring up his files here. And Ramy, I see that you have logged on.
Yeah.
I see your webinar. You are yellow, though, for me. I'm not sure if you are. Okay. Yeah. Sorry, folks. Just a quick technical glitch here.
So
there we are.
Let me ask you guys. Are you ready for me?
Yeah, absolutely. Take it away.
Okay. So I hate webinars and I hate talking at people. So I will look to the chat window for people to talk back to me. So my first question to you is, what are we looking at here? And I don't mind waiting. No answers yet. Okay, so Mr. Josh, you tell us it's a gorilla. Okay, a few people are guessing gorilla. My question to you is, well, that's rude. My question to you guys is, how do we know that it's a gorilla? And usually when we do this interactively, we'll hear answers like, I've seen gorillas in the past. I've seen pictures of them. The real question to you is, what happens when we get it wrong? This is a screen capture from our friends at Google back in 2015, when Google Photos and their object recognition algorithm decided that these two people were recognized as gorillas. This is it on CNN.com, and you can go to most major media outlets and type in Google gorilla and find versions of this story there. It was originally picked up on Twitter when Deary Noir said, Google, y'all fucked up. My friend is not a gorilla. And there's a whole bunch of reasons why this happens. And what's interesting to me is that it's not about necessarily jumping to any sort of conclusion saying the engineers who designed this algorithm are racist or they don't understand humans. It's about context. It's about understanding how do any sort of predictive tools or algorithms truly work. And so if anyone here comes from a kind of a Six Sigma or lean background, you might be familiar with this notion of 5 nines, this notion of being 99.999% right. The crazy thing about being really accurate, which very few algorithms are to begin with, is that they're still wrong sometimes. And if 10 million photos get uploaded to an image recognition algorithm that even is 99.999% accurate, it still means 100 of them are going to be wrong. We won't talk today about how Google solved this problem, and I'll give you a hint, they haven't. But what I do want to introduce is this notion of what's this intersection between human-centered design or design thinking and really building a comprehensive AI strategy. And really today we have like 10 minutes. It's going to be just a touch. I'm going to skip over most of this stuff, and you guys can, there's many other ways to dive deeper into this content. I can share a few at the end of this, but really I want to just introduce this notion that the technology doesn't matter. Very rarely is it technology that's stopping us. It's not understanding what is the problem we're trying to solve, not having the frameworks through which to reframe problems, and not understanding enough about our users and the kind of business context here. So with that, who am I? I do corporate innovation work. I teach at McMaster and Ryerson and U of T and St. Mary's, a range of different courses, mostly in design thinking, some work in data science as well. I have written a book. It's set for publication later this year. Apparently there's a bit of a delay due to the whole global pandemic thing, but most of my time is really spent thinking, when I'm not on a bike, thinking about how can we create better human-centric solutions that use emerging technology in all of its forms, whether deep learning algorithms or augmented reality or whatever the next cool trend is. How can we bring that human lens into the equation and create better solutions that solve real problems, that make us money, and that honestly make people's lives better, because most of this stuff out there is not awesome. So really, let's talk for a couple of minutes about how do we intersect AI with design thinking. What I'd like to do is give you a quick preview of a couple of practices. We're not even going to unpack all of these, but we'll unpack one or two of them. But really just a couple of practices with respect to how do we integrate some of the tools from the field of design thinking or human-centered design or service design and bring them into a very currently technocentric approach of AI. We start with empathy. An actual understanding of who our users are, who we're trying to create value for, is fundamental to all of this. We need to be able to reframe problems. So often we are looking at the wrong problem or the wrong aspect of a problem. And in fact, when we start to unpack a problem, and this is quite often associated sort of with the second phase of design thinking, definition, we can start to see that underneath that problem, there might be some more important ones to actually tackle. And I'll give you an example of one that came from a project I just finished wrapping up. We were looking at the experience for folks waiting in hospital emergency rooms. And this is pre-virus stuff. It was a project with a hospital out on the East Coast. And one of the participants in the workshop, kind of this introductory context setting workshop, suggested, how might we make the wait time in our ER shorter? And immediately it was met with so much resistance. It was crazy. And suddenly one of the co-collaborators said, wait, let's reframe that problem. And all they did was they asked one additional word in that question. And all they did is said, how might we make the wait time in our ER feel shorter? And suddenly there was a flood of ideas that came out of it. How do we get to these ideas? Well, how might we, and problem reframing is the first step. I use the term wild combinations often, but there are some really cool methods, and I'll introduce just one of them in a couple of minutes here for AI, machine learning, data science, other emerging technology-specific ideation techniques. One big gap that I see with the clients I work with, I see in the academic circles, is we don't have all the tools yet to validate the impact of what we're building to be able to actually measure anticipated return on investment, return on marketing spend, return on whatever it is we're doing before we go down the path of building complex models and putting them into production. And then finally, we need new tools to prototype. We've got awesome tools to rapidly prototype mobile apps, to prototype voice interfaces. We don't have them yet, or they're just kind of coming to market, the ones that will actually be applicable to new data models and things like that. So I'm going to skip ahead here because we've only got a couple of minutes, but I'm going to dive into one or two of these. I'd like to introduce this notion of wild combinations. Everyone keeps thinking that they're not creative. It really honestly pisses me off. We were all born creative. When we were kids, we go and we're curious and we're explorer. And sometimes we just need some silly ideas that lead to those creative breakthroughs. And I've watched CIOs come up with ridiculous storylines from doing these wild combinations exercises. And when we peel back those crazy ideas, underneath those crazy ideas, quite often there's a really meaningful new concept. And so one of my favorite things is to use tactile prompts. This is a picture of a couple of decks of cards I use when we're doing ideation around AI concepts, around machine learning, around using various forms of emerging technology. And quite simply put, we'll start with a context scenario, often framed as a how might we statement, and we just start dealing out cards. And there are cards about different interfaces, such as beacons, kiosks, mobile devices, screens, home assistant devices. And then we have another set of cards around prediction technologies, uncovering structure, often related to unsupervised machine learning, supervised prediction tools, object recognition, OCR, all these different things. And we just challenge our teams to say, given this context, this persona, and this set of technologies, tell us a story. And most of those stories are ridiculous. Most of them are silly. Very few of them will ever come to market, but they become the starting point for coming up with those creative new solutions. Again, in our full workshop, we'll spend an hour and a half actually going through exercises on this stuff, and it's much more interactive. But at this point, I want to skip ahead a moment here to the fourth practice, which is validating the impact. You all know data is messy. I hope that many of you are familiar with the notion of a false positive and a false negative, but we don't yet have great tools in terms of actually understanding how do we tune our algorithms to perform for the context we're looking for. So what I mean by that quite often can be represented in something called confusion matrix. I've taken this one and actually taken the liberty of applying it to our good friends at Netflix. We're all stuck at home. We're all watching more TV and movies than we probably should be. So let's talk about what does it mean to apply a confusion matrix to the way Netflix makes recommendation using a range of AI tools for us. So personally, I hate Downton Abbey. I don't find it entertaining. I don't find it interesting. I don't understand it most likely. And so when Netflix realizes I don't like it and it as such doesn't display the new season being released, I'm a happy camper. And equally happy is when a new Batman movie comes out and Netflix predicts I will like it, and I actually will, and it shows up in my home feed. That's a great experience. These are the two easy scenarios to deal with. The problem is that designers, product leaders, innovation champions need to figure out what happens with false positives and false negatives. So what happens when a new Batman movie is released and Netflix, for some reason, doesn't think I'll like it? It doesn't show up in my feed. Well, I might not be too happy about it. I might not be crying at night, but I certainly might be unhappy. And what happens when I turn on my TV and I just want to kick back and relax after a long day of work and the first recommendation for me is Downton Abbey? Probably a feeling like this. I think, come on, Netflix, you don't even know me. I thought we were friends. And so with that, this actually becomes a structure through which we can actually look at a range of prompts or questions that become the basis for having really rich discussions that say, should our algorithm actually favor false positives or false negatives? And we won't go into the data science notion here of precision and recall, but there is a mathematical and an industry kind of set of tools that we can use here. But as we think about these questions, as much as my Netflix example might seem a little silly to you, Netflix accurately predicting and recommending content to me is a core of the value that they bring. And you could actually look at the impact or the cost or the opportunity cost of them if they weren't good at it, if they kept getting it wrong. People would go to competitors. And so as we look at this, we need to look at what is the user experience, what's the impact to the business and the brand. For example, are there privacy impacts that need to be considered? Are there compliance? Are there insurance risks? And then most importantly is that middle column. How does a user recover from when the algorithm gets it wrong? So with that, wrapping up this stuff, again, obviously this is a teaser around it. Start with empathy. Understand who the hell you're designing for. If you don't know who your user is and you're only thinking about necessarily who your buyer is, you're going to build the wrong solution. Reframe the problem from the context of that empathy basis. Ask, how might we? Use a range of tools to come up with ideas. Don't jump to solutions right away. Explore the diverse set of concepts. Sometimes I call it wild combinations. Consider using something along the lines of a confusion matrix and a structure like that around it to validate the impact, and get creative about how you take prototypes out to learn from them. Don't think of a prototype as a blueprint for your final solution. Think of it as something you want to mess up, you want to break, you want to get wrong to learn quickly, cheaply, and systematically de-risk your new concepts. And so with that, if anyone's interested, we do deep dive workshops on this stuff. There's a link there to learn more. We'll be at the event later this fall when we're all back out of our homes running on-site workshops. My contact's there if you want to hit me up. I do believe these slides are going to get shared out with folks. I think I'm right on time. The question that is in the Q&A here is sort of giving an example starting with empathy. I can't show you any pictures of it, but there's a tool called an empathy map. And the purpose of an empathy map is to give a structure to how we understand our users. Because the weird thing about all of us humans, the honest truth, is that we lie. The things we say, the things we feel, the things we think, and the things we do don't all match up. And so an empathy map as an actual tool or an example here is a structure that designers and product leaders and innovation champions will use to actually better understand a customer segment or a persona that they're designing a solution for, and look at what is that person saying, what is that person seeing in the media and the market and the competitive landscape, what are they doing, how are they currently solving this problem? Because quite often, when we go and build a new solution, we've actually thought our solution is best, but we don't really realize that that user's probably already figured out a way to solve this problem. Let's understand the current status quo. All of these fit in under this notion of an empathy map, and they become a basis for understanding our users that we can use to design better solutions. So I don't see any other questions, which gets me off the hook. I will say that our next presenter, Salman, is a dear friend of mine. Up until an hour ago, I didn't know he was presenting right after me. He's attended some of my workshops. He and I are co-creating other workshops. Super stoked that you guys get to hear a little bit from him and Learners.ai. There's one more question here actually that just popped in. How do you take it from theory to execution? How do you convince an executive to start with empathy? Don't even try to convince someone to do this all. Just start. And so I'm a huge, huge believer in saying the whole theoretical concept of 5 stages of design thinking or human-centered design, they're beautiful in textbooks. I got a library full of them, but they're crap in the real world. And the reason I say that, and I say that as a passionate design thinking advocate, is that very rarely will you get to go and restart a project from scratch. So instead, my advice to you is to pull in tools from the world of design thinking and introduce them into your current processes. And when people say, hey, we've never done this way before, you say, oh, great, yeah, I got this exercise from a design thinking textbook or a workshop I attended or a lecture I went to or a webinar I went to. I'm a big believer in bottom-up innovation. I think very rarely are executives actually creating meaningful change in their organization. The number one role of someone with C in their title is to mitigate risk, and new approaches to solving problems have a high perceived risk. And so a few specific tools I can suggest to you are 6 hats thinking. If you're not familiar with that, a quick Google search will pull up lots of work by a gentleman named Edward de Bono, written in 1936. Unbelievable facilitation tool that you can start using tomorrow morning in every meeting you go to. Looking at confusion matrices, looking at things like ideation cards and techniques. I think that all those things end up building sort of a groundswell for introducing design thinking concepts into your organizations. The final question I'll answer with the last minute is, at what point should you incorporate design thinking into your strategy if the priority is to get a POC for AI first? Well, then your strategy is wrong. Sorry to tell you, if your strategy is just to build a proof of concept, and that's your desired outcome, well, then go and build a proof of concept. If your strategy and your desired outcome is to solve a problem for your customers or create value for your customers, well, then you can actually start by better understanding them. And I don't mean that to be critical of any approach, but it's what is the purpose of your initiative? If your initiative is to solve a problem, create value, or ultimately drive business and make money, then start by understanding who you're designing it for. But if your goal is just to build a POC because some executive said build us a POC, you'll have a hard time turning that around. And I've been in that case, and I've built them and explained to people that this won't solve our problem, but here you go. We used AI for the sake of AI. These days, I just say no to that kind of stuff, but I work for myself, and I'm fortunate that I get to say no to things that I don't like to do. So it's a very short answer to your question. I want to be respectful. I'm so stoked, to be honest, to get here Salman's presentation. So I'll pause there. Gunpreet, you can definitely reach out to me, and I'm happy to chat and shoot the shit with you a little bit more. But with that, I'll hand it back to Kim and Justin, and then onward to Salman. Don't leave. He's awesome. Really stoked to spend some time with you guys. Thank you.
All right. Thank you so much, Ramy. And as he said, he is hosting a 1-hour workshop at the conference on September 28th and 29th. So this really is the tip of the iceberg of everything that he will be presenting and showcasing at the conference. So thank you so much, Ramy. We really appreciate it. We are going to move on to our last speaker. Just pulling up your slides here, get everything showcased. And Salman, are you with us?
Hello, can you hear me there? Oh. Hi. Hi, can you guys hear me? Okay, all right. I guess we'll get started. Okay, thanks everyone for having me here. Great introduction there by Ramy. It's going to be hard to follow that. A lot of great content, but I'll try to keep it as interesting as possible, folks. So hang in there with me. I'll tell you a little bit about background and why you're seeing this title. Because of my past experience, I've been in the banking and financial industry for more than 10, 12 years, especially focusing on capital markets and wealth management. So really finance is my area. I've been mostly focused on technology implementations, and I've worked with very large organizations doing enterprise-wide programs. So I will try to share a little bit about my experience. I'll have some stories, some lessons learned, especially as it relates to how are things happening with relates to AI and data science today. We see some really cool use cases, but we see some horrible stories where they offer a good learning experience. So I'll try to share some of those in the time that we have today. I want to talk a little bit about Learners.ai as well. We are, again, just focused on deploying AI solutions. Of the large pool of AI companies that you have there, our focus is really in the financial domain. So we focus only on deployable use cases and not even just like research. And we also have our training and professional development arm where we have specific courses for traders, portfolio managers, fixed income analysts, to teach them how they can deploy these models in their own organizations. We're really, a closely connected network of contractors. There's a lot of interesting things that are happening across the whole financial industry, not just in Canada, but I think even down south. When you look at it, there's a lot of cool things happening. So I've been quite fortunate to be involved with some of those things. I've led some of the large programs, especially here in Canada. I'm currently involved with a large pension funds engagement right now as well. So just to kind of give you a little bit background about the type of projects that I've worked on in the past. Done a trading system implementation for a large pension fund, Ontario teachers, and they wanted basic capability for algo trading. Now, what that involves is you have a huge amount of real-time data coming in, and your architecture, your infrastructure needs to be robust enough to handle that, and it needs to be scalable for your users. I've been involved with a couple of digital transformation programs, which were involved in automating the entire client onboarding process. This has been a challenge for a lot of the big firms. I personally know of people who've been involved with 5 or 10-year engagements who are with one of the big banks, and they have consistently failed to automate the customer onboarding process. Now, this is a huge cost saver for a lot of financial institutions. So I have been very fortunate to be involved in that, and this is something cool that you're gonna start seeing a lot more of from other players in the financial industry. And currently, my most interesting one that I'm working on right now is with IMCO. It's another provincial pension fund, and they are basically preparing the foundations of their infrastructure to be AI ready. An interesting thing to note about all of these use cases is what you see is that most of these firms, especially the ones that are doing the right things, they're really getting their data infrastructure ready right now. They're not even that mature enough to go fully AI, like in some use cases that we've seen, where you would think algorithmic trading or computers just thinking on its own and doing trades. There is a lot of that with specialty hedge funds, but with the big larger institutions, they're not that mature. They have legacy systems which are still mainframes. Most of the banks on the Bay Street, especially the big 5, they're all running on IBM AS400 mainframes. So it's really old legacy technology, right? So you have to put that in context. And when we are designing these programs, there is a big leap of faith that you have to come across, and it requires a lot of education on your part too when you're leading these initiatives for the executives and anybody who's involved in these projects. So this is where our industry is right now. It's really at the layer where you're building robust data pipelines and data infrastructure, but the use cases of like fully intelligent automation and using intelligent predictions in fully autonomous decisions, it's not completely there. It is coming there, but not fully there. So what have I learned in my projects, especially the digital transformation ones? These are projects where you have to completely rethink an entire process because you're automating it. And you want to track it, because if you can track it, you can optimize it. And these think a new framework to how you think about it. And what I've learned is how you manage a project or an engagement. It really depends on what you're trying to do. So I'm going to talk a little bit about that. I did want to mention that Ramy's presentation really was good. And the reason I attended this workshop because of the focus on design thinking. And I think this is something that is coming more streamlined. More and more firms are adopting it. It is becoming recognized as being very effective. So it's definitely something that people should look into. This is an approach I've used in the past as well for designing client portals. And I found it very effective to have actual clients on your demos and interviews. So it really helps. So getting into the meat of the presentation, what I want to talk about is things that you need to establish as you start a project. First, you need to recognize, like, what are you exactly doing? Like, are you doing a project or are you building a product? Because if it's a product, you're probably looking at a series of projects. And if so, what is the interaction between those series of projects and what is the project that you're going to deliver now? So you need to really understand that. And this is also a hint to knowing the environment that you're working in. The organization that you're working in really dictates the methodology and the approach that you're going to use. I've been at places which are strictly agile. I've been to places that have been very strictly waterfall. I've been to places where they are actually waterfall, but they think they're agile. And I've been to places where they're nothing. They're just going around like chickens cutting off their heads. So you really need to understand and adapt to your methodology and approach, your templates, the artifacts, the timelines, the plans, the artifacts that you present, everything according to the environment. You need to figure out who the right players are. You need to establish a relationship with them and understand where they're coming from. You need to understand exactly what they're looking for and what everyone's success criteria is, because success looks like different for different people. Okay, in a big firm, there's competition, there's politics, and there's competing priorities. So you need to understand those and be in the right position, understanding those priorities, because not ignoring the ones that you don't like is going to crush your project. Secondly, one of the other things that you need to do is build the right team. There's a lot of mixes that I've seen in different places, different projects, but this is a list that I really recommend as many people with these skill set that you can find, or as many of these items you can find, the better. A project manager, a business analyst is really important. An information designer is somebody that's like a business systems analyst who can really be the bridge between the business and the data scientist, which is also an important role. A data engineer and a visualization or a user experience designer. This one I would recommend to be as important as the project manager. Then you have to clearly identify all your integration points, especially in large firms. What you don't know comes to haunt you later. It's these legacy systems, and finding out about them later is really what's going to crush you. So the sooner that you know all your integration points, where your data is coming from, where it's got to go, any security or any encryption techniques that you need to be aware of, that you need to know those upfront. Okay, evaluate everything. Hear everybody out. See what people are saying. Most of the time, the solution to the problem is right in front of you. So talk to the people, find out what's going on, hear everybody out, and when you have ideas, run it by people, validate it. Always validate. Always validate. Show it to people, confirm it. Get compliance on board early on. That is the biggest blind spot when you're dealing with financial organizations, because you don't know what they're going to throw at you. So having somebody from compliance on board, on the team, integrated is an excellent idea. Okay, moving on. Once you have your ideas, you need to make sure that you have solid buy-in, that people are not just saying that in meetings, but they are also fully on board. You just don't want people hedging. You want people to be fully excited and be on top of the solution with you. One of the things that I've noticed is the best solution is the one that makes everybody happy. It's not the one that earns the highest returns. So always keep that in mind, because in the end, it's the politics that wins. And you have to understand what the tide of the river is. Okay. If you have more executives on your side, then the better it is. So have them on board, and make sure that they are as excited about it and talking about it as you are. And finally, you need to have have some purpose established for the project, right? Why does it matter? um, and if people have some sort of alignment with it, whether it's personal or a passion project, or some kind of corporate objective or a bonus, then the better it is, right? You get better outcomes. um, Once you have all of that, you need to formalize it, put it in writing, get people to approve it, put concrete plans out, establish timelines, and let everybody know how you're going to communicate about the project, how you're going to send out updates, or how are they going to find out about it, how to be track progress and communicate with everybody what's going on. That's very important, because if you want people to be on board, you need to make them feel important and have them participate, and which is really the final point in the presentation as well, is the importance of change management. Because if you fail that, you really fail the project. You have to democratize your solution. You have to market it. People have to know about it. People have to be excited about it. They need, and one way of doing it is you're constantly soliciting their feedback. You're showing them demos, even if they're not one of your direct stakeholders, but they're going to be your users one day. You need to just keep them involved and let people in on what you're working on, so that you get more participation, more enthusiasm from everybody. And you have to track what your product is doing. You have to see how effective it is. So you have to know what metrics to track. Are you tracking usage patterns, how long people are online, or how many people have signed up? All depends, right? How are you tracking usage, and are you meeting those targets? So you need to be aware of those, and you have to constantly keep people engaged. So let them know what's coming next. That way they are in it, and interested in it, and they keep coming back and staying engaged. Because when they are users, they are going to be in it all the time. So those are some of the key lessons that I've tried to squeeze in the last few minutes. It sounded like a speed question round, but hopefully you got something out of it, and happy to take any questions if there are any. You can also send me an email if you want to follow up and connect. I'm happy to chat later as well.
All right. Thank you so much, Salman. We really appreciate it. Fantastic insights. And I'm sure if any other questions come in the next 30 seconds, if we can address them really quickly, or if any questions come in after the webinar, we'll be sure to send them over to Salman. He can answer them and we can submit them.
Sounds good. Thank you.
No problem. Thank you. I think we're going to have to move on, unfortunately. But yeah, again, if you have any afterwards, we're happy to send them to him.
Thank you.
Thank you. Oh, actually, we did have one come in, Salman. What are the advantages of adopting change management versus project management approaches?
I think change management should be definitely integrated within your project management approach. Change management is really to make sure that your launch is successful, and that it gets buy-in post-deployment, and that it gets integrated within people's behaviors. So I think you should integrate practices of change management within your project management. That's really a key element.
Okay. Well, thank you so much.
Thanks.
So thank you to everyone who attended this week's webinar. We appreciate you staying with us for our second installment. Our next webinar is going to be taking place next Thursday, April 23rd, and we're going to be talking about rethinking privacy in an AI-driven world. We'll have speakers from PwC and Huawei attending and speaking on this topic. So we're really excited for next week's. Just a reminder, the recording of this webinar should be available next week on our website. If you missed our webinar from last week, Modern Approach to Big Data, it's also on our webinar, so make sure to check that out if you missed it. Additionally, there will be a survey going out after this webinar. We really appreciate any insight that you can give us on that survey, just so we are building and hosting webinars that we know are relevant and meaningful to you all. Again, any unanswered questions for presenters will be sent to them after the webinar concludes, and they have the option to fill out those questions, and we will send them to all audience members. So thank you again. We really appreciate you guys logging on and learning and growing your skills with us during this time. And we really look forward to hosting another one next Thursday, and we hope that you can join us.